When Mars 2020 Perseverance reaches Mars, it will be the 9th spacecraft NASA has landed on the Red Planet in 40 years. It is incredibly difficult to land a spacecraft on another planet, and NASA wants to send humans to Mars one day in the not-too-distant future. So I've asked entry, descent, and landing expert Michelle Monk just what it is that makes landing on Mars so difficult, how we're able to do it, and what technologies we'll need in the future to put humans on Mars.
When we think about landing humans on Mars, we're going to have to land the equivalent of a 2-story house. When we reach the Mars atmosphere, we're traveling about 13,000 miles an hour. And so to slow down all that mass, we're going to need a large heat shield. Right now, we use heat shields that can fit inside our launch vehicle shroud, but we need something much bigger. We're using the concept of a hypersonic inflatable aerodynamic decelerator, or HIAD, an inflatable heat shield that is folded up inside the launch vehicle and then expands to encapsulate our vehicle and provide the area and the thermal protection we need against the excessive heat of entry. We're actually testing the HIAD next year at the 6-meter scale. That's the biggest heat shield that's ever entered an atmosphere.
So we use a heat shield to protect the payload from high temperatures, but what do we use to slow the whole payload down? The answer, rockets.
After we get through that high heating portion of the trajectory, we're still going about 2,000 miles an hour and need to slow down more. Parachutes just aren't effective. They'd have to be as big as a stadium. We have rockets with us to land softly on the surface, and we're just going to turn those rockets on a lot sooner than usual at supersonic speeds. This has never been done at Mars. It's a very difficult condition to replicate and test at Earth, and so it's going to take a lot of analysis to make sure we understand how those rockets and their plumes are going to affect our vehicle and its control as we get closer to the surface.
Some of those precision landing technologies that we'll need to land humans on Mars one day are already being developed and tested now.
Yes, we need to precisely land and we need to avoid hazards, both natural hazards like rocks and craters and things that we've put on the surface earlier to support the humans. Both of those things are going to take some very advanced sensors. For precision landing, we're going to use terrain relative navigation to really pinpoint our location on the surface. Mars 2020 is actually flying that technology for the first time, so we'll get to see how it works. Then we're going to use a navigation Doppler LiDAR and a hazard detection LiDAR to get us down to the surface. The navigation Doppler LiDAR will give us a very precise velocity and distance to our landing site. The hazard detection LiDAR will give us a real-time map of the hazards in the area so that we can avoid them.
But even once all of those precision landing sensors kick in, the landing is still not complete. We're still not on the ground yet.
Now we're really close to the surface. We found our safe landing site and we're on our way down. But we have 8 huge engines under our vehicle pointed down at Mars, and they might dig a huge crater as we try to land. In order to understand the effect of these plume surface interactions, we're advancing our modeling tools and doing ground tests to anchor those computer models so that we can better predict what's going to happen. We're really excited about this area because it's also applicable to lunar missions. As we send small robotic landers up through human scale to the moon with Artemis, plume surface interactions will be very important. We can't easily test this large system in the right conditions at Earth, so we rely heavily on computer models and simulations to make sure that the system's going to work from entry all the way through landing. Langley has over a century of expertise in atmospheric flight, and so we're applying all of that history and knowledge to our flights to Mars. NASA Langley is leading the way in developing the entry, descent, and landing technologies we'll need for future Mars missions and for eventually putting humans on the surface.